What are we gonna search up for today? Hey, why not search up about machine learning? Now, before we delve deeper into the realm of machine learning, let's take a look into the quote of the day. Any sufficiently advanced technology is indistinguishable from magic, by Arthur C. Clarke. An immediate question would pop into your mind. What exactly is machine learning? There is a lot of data that's produced not just by humans, but by computers, smartphones, and other devices. Traditionally, we would analyze data and adapt systems and patterns to match with those data. However, as the world of technology improves, our human minds are limited to interpret those data, which is why we resort into automated systems that can analyze those data more efficiently. Alright, how is machine learning used? Now, let's take a prominent example, the Google search that we used every time and everywhere. Every time you use a Google search, you're using a system that's made up from tons of machine learning systems, ranging from understanding your text that you typed out to adjusting the results based on your personal interest. For example, when a user searches up the word keyboard, the results could vary whether the user is a tech geek or a pianist. Moving on, what is the importance of machine learning? As we use machine learning to improve human tasks better, we can expect machine learning to help us perform tasks that we have never achieved on our own. A great example would be the fact that modern hospitals have their own machine learning algorithm that can process vast amounts of medical imaging data to recognize various of diseases, such as early stage cancer. This early detection can be crucial for effective treatment, improving the patient's outcomes. Alright, in short, we can say that machine learning is using data to answer questions. However, we can split this into two definitions. Using data can be referred to training. Answering questions can be referred to prediction. We have something called a model, which is used to train and produce predictions as a result to answer the questions given. The more data that's given, the more accurate the result is.
So next, we will move to types of machine learning. So basically, there is three types of machine learning. First is supervised learning, next is unsupervised learning, and the last one is reinforcement learning. First, supervised machine learning. As the name suggests, supervised machine learning is based on supervision. It means in the supervised learning technique, we train the machine using the labeled dataset, and based on the training, the machine predicts the output. For the example, let's say we have the labeled dataset of cat, such as the shape and size of the tail, shape of eyes, color, height, and size of a cat. It will provide the training to the machine to understand the image of a cat. After completing of training, we input the picture of a cat and ask the machine to identify the object and predict the output. Now the machine is well trained, so it will check all the features of the object, such as height, shape, color, eyes, ears, and tail, and you will find as a cat. So you will put it in the cat category. Next, there is two categories of supervised machine learning. First is classification algorithm. It used to solve the classification problems in which the output variable is categorical, such as yes or no, male or female, red or blue. For example, random forest algorithm. In random forest algorithm, there is two sets, training set and test set. In the training set, with the data given, the machine will train and make a decision. And in the test set, it will vote to get an average of the decision and predict the output. Next is regression algorithm. Regression algorithm used to solve regression problems in which there is a linear relationship between input and output variables. For example, simple linear regression algorithm. Like we can see, there is a relationship between x and y in the graph. The greater the x, the greater the y. The second one is unsupervised machine learning. In unsupervised machine learning, there is no need for supervision. The machine is trained using the unlabeled dataset. The main aim of the unsupervised learning algorithm is to group or categorize the unsorted dataset according to their similarities, patterns, and differences. For example, imagine there is a basket of fruit images, and we input it into the machine learning model. The images are totally unknown to the model, and the task of the machine is to find the pattern and categories of the object. So now the machine will discover its pattern and differences such as color difference, shape difference, and predict the output when it is tested with the test dataset. And the last one is reinforcement learning. Reinforcement learning works on a feedback-based process. When we input a raw data, an AI agent automatically explores its surrounding by hitting and trail, taking action, learning from experiences, and improving its performance. Agent will go to environment and get rewarded for each good action and get punished for each bad action. Hence, the goal of the reinforcement learning agent is to maximize their reward, and it will continue the process until get the best output. On another words, the reinforcement learning process is similar to human being. For example, a child learns various things by experiences in his day-to-day life.
Machine learning could be applied in many different sectors in real-life problems. For example, healthcare, transportation, manufacturing, and agriculture. In the healthcare sector, machine learning models are used to diagnose diseases. This is done by analyzing medical records, images, and patient data to assist doctors in diagnosing diseases like cancer, diabetes, and heart conditions. Besides that, machine learning could also identify new drugs by analyzing their molecular structure and predicting their efficacy. Moving on to transportation, machine learning is essential in automating vehicles, which we could see more of nowadays, by helping drivers navigate and make real-time decisions like swerving into a different direction if we got too close to another vehicle automatically. Machine learning could also forecast traffic patterns to help choosing the best route and reduce congestion during peak hours especially. In the manufacturing sector, however, machine learning are used to identify defects in real time during manufacturing process, thus reducing defects and improving product quality simultaneously. Another application of machine learning in manufacturing could be seen where machine learning could predict the equipment that requires maintenance beforehand, which is important in order to keep a constant flow of manufacturers. Last but not least, machine learning are applied in agriculture, where machine learning are used to monitor crop health by analyzing satellite imagery and sensor data, as well as identifying and track pest infestations in crops. Moving on to a few examples of machine learning advantages. First of all, it provides automation which could reduce the workload of humans overall. Next, machine learning models can adapt and improve over time as they are exposed to more data, making them suitable for dynamic and evolving environments. Machine learning also can make accurate predictions and forecasts such as equipment failures seen in manufacturing sector. Lastly, machine learning enables personalized recommendations and user experiences such as personalized content suggestions on streaming platforms like Netflix. Despite having many advantages, machine learning also have their own number of disadvantages. For example, machine learning heavily depends on the quality and quantity of data received, where if given wrong data, it could completely become obsolete. Besides that, machine learning models require ongoing maintenance and monitoring to ensure they remain accurate and relevant as data and circumstances change. Following that, some machine learning algorithms and models can be computationally intensive and require significant computing power, making them less accessible to smaller organizations. Last but not least, machine models can be vulnerable to adversarial attacks where malicious actors manipulate input data to deceive the model's predictions.
Now, I will talk about challenges of machine learning. First of all, poor quality of data. For your information, data plays a significant role in the machine learning process. Therefore, the quality of data is very essential to enhance the output. Now, let's move on to the step for data reprocessing. The first step is data completion. The second step is data noise reduction. The third step is data transformation. The next step is data reduction. And the last step for data reprocessing is data validation. Other than that, underfitting of training data is also one of the challenges of machine learning. Underfitting of training data occurs when data is unable to establish an accurate relationship between input and output variables. It signifies data is too simple to establish a precise relationship. The next challenges of machine learning is overfitting of training data. So, what is the meaning of overfitting of training data? Overfitting of training data refers to a machine learning model trained with a massive amount of data that will negatively affect its performance. This means that all the algorithm is trained with noisy and biased data, which will affect its overall performance. Last but not least, slow implementation also is one of the challenges of machine learning. Basically, the machine learning models are highly efficient in providing accurate results, but it takes a tremendous amount of time. Did you know that slow programs, data overload, and excessive requirements usually take a lot of time to provide accurate results? Therefore, it requires constant monitoring and maintenance to deliver the best output. The next subtopic that I will discuss in this video is the future trend in machine learning. First of all, no-code machine learning. So, what is the meaning of no-code machine learning? Basically, no-code machine learning is programs application without the lengthy process of reprocessing, creating models, training, and deploying the models. No-code machine learning will give us a lot of benefits, such as saving time and cost. Other than that, no-code machine learning also offering flexibility and speed. Next, natural speech understanding process automation is also one of the future trends in machine learning. For your information, natural speech understanding process automation is one of the most popular trends for machine learning apps. For example, the existence of voice assistants like
Hey Siri.
Hey Google.
Hey Alexa.
The most powerful thing about natural speech understanding process automation is it has great degree of accuracy when it comes to hearing human sounds. It also can connect to smart appliances without any contact control. The last future trend in machine learning that I will discuss for this video is metaverse. What is the meaning of metaverse? Metaverse can be any 3D virtual space powered by technologies including virtual reality, or also known as VR, augmented reality (AR), and also artificial intelligence (AI). Metaverse play a crucial role in developing platforms by streamlining processes and enhancing user experiences. Streamlining processes is very important as it can improve productivity, increase cost efficiency, superior time management, enhance communication, and also risk minimization. So basically, user experience focuses on having a deep understanding of users, what they need, what they value, their abilities, and also limitation. User experience have a lot of components such as performance, functional analysis, feedback, usability, efficiency, development, task analysis, and last but not least, digital strategy. For metaverse, which is one of the future trends in machine learning, individuals can engage in various activities such as they can establish virtual life, generate income, and conduct business.